Sometimes we can't find the analytical integration of a function. It's not integratable. It's too complicated. Or we have a graph here, but we have a graph here of the curve of which we want to find the integration, a definite integral from a to b, let's say x. So then we can use numerical methods. So the methods that are normally used, the first one is, the simplest one is the rectangular rule. So basically what is done, we divide the graph into several small rectangles. So this is, let's say, y0, this is y1, y2 and up to yn, and equal all the equal differences. So basically all of them are del x, so equally separated. So that result will be del x times y0 plus y1 plus y2 up to yn. So basically finding the area of all the rectangles, and when we do it, we, of course, it's an approximation, it's not a correct one, we encounter some errors. So yeah, this is how the error will be. Sometimes it will be bigger, sometimes smaller. So this is the simplest one, the numerical one. Then it's a better approximation is, instead of doing a rectangle, if we do a trapezoid. So we take the trapezoids like this and then so on. So we know the formula for the area of a trapezoid is, if we say a trapezoid is this one, this is y0, this is y1, so, and this is del x, so the area is del x over 2, the difference, the separation between the two parallel lines divided by 2 multiplied by sum of the parallel lines. This is the area of a trapezoid. So the area here will be all the trapezoids. If we sum them up, del x, this will be y0 del x over 2, y0 plus y1, then the second one will be y1 plus y2, then y2 plus y3, so on, and so on, it will go up to yn. So it will be like this, basically y0 plus 2y1 plus 2y2 plus 2y3 plus 2yn minus 1, and finally yn minus 1. The last one will be just y. So that will be the area. And of course, the more number of trapezoids or rectangle we can divide the curve into, is the better approximation, of course. But there is, of course, always a limit, and so that's, we have to. But if we can do a software, we can do it numerically, then it's the more we can use, the better it is. And another one which is called Simpson's rule, I will just write the formula directly. So Simpson's rule is like this. So we have del x, which is again the separation, but then the formula goes like this. If we say k is equal to 1 to n, this goes like yk minus 1 plus 4yk plus yk plus 1. This is how it is. So it becomes, the first one becomes y0, then 4y1 plus 2y2 plus 4y3 plus 2y4 and so on. So the even ones are multiplied by 4 and the odd ones are multiplied by 2. That's how the section becomes. And the first one is, of course, 0 and up to yn. So that will be 4yn minus 2 plus 2yn minus 1 and finally yn. So that's how the Simpson's rule to find this is how the Simpson rule goes to find the integration, which is basically area under the curve. So we are trying to find the area under the curve, which is the integration, the definite integral. So these are the normally used in numerical methods.